Two popular messaging systems today is Kafka and RabbitMQ. You might hear them both. Both RabbitMQ and Kafka are excellent open source solutions for messaging system. But what is the difference? In this lecture, we will see some high-level difference of them. By the way, I have course for both of them using Java Spring. You can see the detail and special price on last lecture of this course. In this lecture, you might be confused with the terms like exchange that exists on RabbitMQ but not Kafka, or partition which exists in Kafka but not in RabbitMQ. That's okay, I will try to explain in brief, and if you're interested in more detail, you can always go to last lecture of this course. In Kafka, message retention is based on policy. Every message will be stored at your disk up to a certain time period that you can set. For example, if you need the data to be stored weekly, you can set the retention period of message to 7 days before it became unavailable. With such policy, when a Kafka consumer process M1, M2, and M3, all of them will remain on disk for 7 days, and another consumer, or even the same consumer, can process M1, M2, and M3 again. RabbitMQ stores the message in memory or disk based on your choice. The message will be stored until a consumer acknowledges, that is, a consumer confirming that the message has been processed successfully. So, one message, one successful process from one consumer, and the message is gone. If we need to process the same exact message, the publisher must republish the message. Kafka does not have routing mechanism for message. RabbitMQ has routing mechanism using exchange, which routes the message into one or more queue. In Kafka, the publisher tells which topic to write and optionally tells partition, and Kafka will publish the message to that specified topic. RabbitMQ can route the message based on routing key. There are several exchanges available: fanout, direct, and topic. Each has different functionalities. The publisher can attach a routing key, and RabbitMQ will route the message to one or more queue to be consumed. Kafka achieves multiple consumers by using partitioning. Each topic in Kafka can have multiple partitions. Each partition can only has one consumer per consumer group, so message order in Kafka is guaranteed. In RabbitMQ, one queue can have multiple consumers. This might be useful if we have fast producers and slow consumers. However, there is also a drawback by RabbitMQ approach. Multiple consumers might cause a pattern called competing consumers, where messages in queues might not process in order. On message retrieval, both has opposite way. Kafka consumers pull the message from Kafka topic and partition, so the active part is the consumer. This pull model also guarantees message ordering, since one partition can be accessed by maximum one consumer. RabbitMQ is the opposite. RabbitMQ will push the message into each registered consumer. To avoid flooding the consumer, in case publisher works on faster rate than consumer can handle, consumer can set the prefetch limit, which is basically number of unprocessed messages that can be accepted by consumer. This push model ensures that message workload is distributed fairly even among consumers. So, which one to use, Kafka or RabbitMQ? Well, the decision really depends on the use case. I know some fast transaction companies, like e-commerce, use Kafka as their core messaging. In several other companies with less transaction rate, they go with RabbitMQ. RabbitMQ, in my experience, is somewhat easier to manage. You install it, and it works generally fine for message broker. With Kafka, there are several things to be managed, like the cluster application, producer, and consumer config. But Kafka is good for scalability, and usually a choice on big data streaming. Like in bank, the transaction from ATM, credit cards, and other channels can be streamed to Kafka and analyzed for fraud possibility. From developer perspective, both Kafka and RabbitMQ has good support for widely used programming language. In Java, we can use Spring Boot that provides ready-to-use functionalities to talk with Kafka or RabbitMQ. Both also provides libraries for popular programming languages like Python, Go, or C#. But I have worked with developers that never know about message broker before, and it seems that the learning curve of RabbitMQ is somewhat easier. But this is only my personal opinion. So, discuss with your organization before take the decision. But I strongly suggest that in one organization, we only stick to one message broker product. Otherwise, there will be double effort to maintain and work with them. Thank you.